So my wife and I are all excited. We go into the movies. It's the Spider-Man film. You know, the one with Tobey Maguire? Gosh, that was quite some time ago already now. They've probably already remade Spider-Man like 3 times. But anyways, we're in the film. We come out and there is the driver's side of our window smashed. My sunglasses gone. What I failed to do was any type of a defense in depth strategy. You could see my sunglasses sitting on the dash of the car. Like a fool, I don't have them in their case, a non-descriptive case. Like a fool, I don't have that case tucked in the console. Like a complete moron, I don't have that console locked. You see, there were various levels of security that I could have used for my, by the way, first ever in my life expensive pair of sunglasses, but I did none of those. As a result, I had my information breached. In this nugget, we're going to go ahead and take a look at securing our storage infrastructure. And we will begin this journey theoretically, talking about things like security frameworks and the risk triad, and breaking things up into security domains. But then I'll get real specific with you, and we will discuss the very, very specific mechanisms that we will often use to secure storage. So what really happened to me? Well, a key part of the security framework had hit me square across the face. I had failed to secure my stuff's availability. And this is certainly something that we want to watch out for in our storage infrastructure. Remember, one of our goals is that business continuity. We need to make sure the data that our employees need is available when they need it. And if someone steals it or corrupts it, then we've failed. By the way, corrupting the information is what we refer to as the integrity of the information. When you send data from your data center out to someone's, let's say, iPad mini all the way across the globe, if that data is manipulated in transit, we say the data now lacks integrity. So we want to guard against that. Confidentiality is keeping stuff that we don't want people to read in an unreadable format. So let's say we're subject to what's called a man-in-the-middle attack. We are sending data from a data center to another data center. They grab that data. With the appropriate level of encryption, we can ensure confidentiality. Sure, they have the data, but they're not going to be able to read it as a result of that encryption. Notice I said the appropriate level of encryption. And one of the things that we have to deal with when it comes to encrypting information is making sure that we're doing so within the bounds of the law. You see, governments want to make sure you're not encrypting stuff to the point where they can't decrypt it for nation security and things of that nature. Accountability refers to us tracking everything that goes on with the data. So if there is some kind of a breach, or if someone is doing something wrong, we want to be able to find out exactly what they did, when they did it, and hopefully who it was. Now, I already alluded to a theme that we're going to have as we move throughout this particular nugget, and that's defense in depth. The first time I heard about defense in depth was actually studying Cisco security technologies. In fact, I'll demonstrate one of their technologies in this nugget because it's perfectly appropriate. Defense in depth means these multiple layers of security. But something else that we're going to discuss in this particular nugget, and will be a recurring theme, is breaking things down into domains, because really that's the only way that we're going to be able to effectively secure things, especially in today's extremely complex compute environments. So one of the things we like to do is set up a risk triad, and we like to break our things down into these three categories. We like to think in terms of our assets. Obviously, a hugely important asset is your digital information, the stuff that we are asked to store. But remember, it's not all created equal, is it? You have a lot of information that you're storing that is for public consumption. Sure, you don't want it altered because that could cause embarrassment and things of that nature. In fact, I just think of all the many times that public websites have been defaced to dramatically embarrass the organizations. I can remember both the CIA and the FBI having their websites defaced. But anyways, you get the point here. That is nowhere near as tragic as like FBI, spy information being stolen. And you can probably tell that I'm currently in season 2 of FX's The Americans, talking about spies. But anyways, you get the idea. Not all of your assets are created equal, and you need to delineate between them so that you know which to provide the extreme levels of protection to and which just aren't that critical. The other thing that we need to be aware of is the threats. Threats are going to be internal employees. Don't forget about them. They're going to be external forces that are trying to come in. And we also have to try and get a handle on what vulnerabilities exist in our infrastructure. Perfect example would be we're running EMC storage equipment and there's been the notification of a vulnerability in that storage equipment. There's a patch that we can download and implement that will fix it, but we need to try and stay ahead of the vulnerabilities that exist in our infrastructure so that these threats don't succeed in violating confidentiality, accessibility, integrity, or accountability. How could someone really mess up accountability? Well, a great example of that is being able to change the time. We typically use something like network time protocol in order to keep time beautifully synchronized to an atomic clock across all of our devices. Maybe they will circumvent that, changing time, which obviously impacts the validity of our accountability. But just breaking things up as far as what are our assets, what are the threats, and what are the vulnerabilities that exist doesn't really do the job. What we like to do in the security infrastructure is we like to go in and say, all right, look, we're going to break things up into domains and attack them separately for those different areas. So one of those domains would be, for instance, application access. And we'll cover the specific things that we're going to be doing in a moment, but things like access control lists and zoning and automating and auditing and role-based access control come into play. For management access, we make that a separate component, and we make sure we're utilizing secure protocols, and we're segmenting the management traffic out of band from the data traffic as much as humanly possible. And then we also will typically recognize in the storage area of the backup, replication, and archive capabilities, making sure we have strict physical controls in place and that we have some very highly protected disaster recovery site that we can fail over to in the event of some huge problem with our primary site. So what are the specific mechanisms we would utilize in order to secure our storage infrastructure? Well, here they are. And I'll go ahead and pause here a moment as you can perhaps screen grab this. You know what? Oh, gosh, I'm so silly. I will put this in the Nugget Labs files for you so that you can make this for your flashcards. It'll be very simple for you. Here's our fiber channel SAN as an example of a SAN. Here's a NAS and here's an IP SAN structure, and you can see just some of the security mechanisms that you would utilize. Things like security zones and LUN masking and zoning. Wait a minute. Security zones versus zoning? What's going on there? Well, yeah, the idea here is you're breaking down the fiber channel SAN into various zones, like from a host to the switch. You would consider a zone, and then you would think about what particular security mechanisms are appropriate there versus the zoning that we talked about when we talked about fiber channel in this particular course. Virtual SANs are a great idea. Role-based access control is a great idea in the fiber channel SAN. NAS. When it comes to this particular form of storage, it's often about things like the careful control of permissions using various access control lists, oftentimes in order to get the job done. In a Windows environment, we often break up the ACL concept into discretionary access control lists versus system access control lists. Discretionary control who can access what, and system access control lists will determine what exactly is going to be audited. What do we need to track from an access perspective? Notice in the IP SAN we have things like CHAP and the ISNS discovery domains that are going on. Probably the least tested area, I would think, in our storage security mechanisms, with an emphasis definitely being on the SAN and the NAS. Now, one of the things that we're going to see a couple of times in this particular nugget is this concept of a firewall. And this can be implemented virtually or physically. It can also be implemented in software. This would be like a physical implementation, but through the software that's been written. So firewalls, hugely important. And keep in mind that when you're doing access control lists, you're essentially firewalling. But I thought what I'd do right now is a quick demonstration of Cisco's firewall that is so often used in conjunction with EMC storage environments. Let's take a look at the premier firewall product for Cisco systems, the Adaptive Security Appliance. So what I've done here is I've fired up a product from Cisco called Vyral. And this is really cool, new invention from them that allows us to virtualize instances of their equipment for practice. So here we're virtualizing what would be an inside device. Here's an outside device. And here's a virtualized Cisco Adaptive Security Appliance. Now, it's going to look, taste, smell just like a real ASA to me as I'm working with it. But the beauty is I don't have to go out and buy an ASA. So this is virtual equipment for the purposes of lab practice. Now, what I've done is I've gone in and set up this device, and I've gone in and set up this device, but I've done absolutely no configuration on this Cisco ASA. So it's like we took it out of the box, plugged it into the inside network and the outside network, and we've just turned it on. So you're going to get to see what it would be like to bootstrap one of these network-based firewalls. So here we are at the command prompt of our device, this Cisco firewall. We start with enable in order to get into a mode that allows us configuration. And then we configure the interfaces. That's all we have to really do on this device initially. Watch this. So I go in and I give an appropriate IP address, 10.0.0.5 on this particular device. We give our mask. And then we name the interface. This is going to be the inside interface. And we set a security level for this interface. This is the highest security level that we can give. It's a number from 0 to 100. And this is saying, look, this particular interface connects to the protected inside world, so we need the highest possible security level, and then we shut the interface. Now, what you would want to do right away here is test connectivity to a device on the inside world. And we have that pre-configured inside device, so I would do a ping test. I would see if we can get to that inside device, and we can. So that interface looks like it's been set up appropriately. Great, now let's go to the other interface on this device that we need to set up. So that's interface gigabit 0/1. I'm going to say IP address 10.0.0.9 in this case with our mask. And that's 252. And then we're going to say name the interface. This one's going to be outside, and it's going to have the worst possible security level, the least secure of 0, because it's connected to the outside internet. And then we're going to say no shut. Once again, we'll want to make sure this particular interface can speak to the device that I have pre-configured on the outside world, and it can. So believe it or not, we're done. What we've done here is we've configured this as the inside interface, and we've said you are the highest possible security level. We've configured that as the outside interface with the lowest possible security level. And now the adaptive security appliance starts doing its thing. What is its thing? It's protecting the inside world from outbound access, and it's allowing the inside world to go out and the appropriate return traffic to come back in. So is it a permissive or a restrictive model? Well, it's kind of both. It's restrictive from connections initiated from the outside, but it's permissive as far as stuff initiated from the inside. Pretty remarkable that it functions with this level of intelligence out of the box. Now, obviously, if you want to punch holes in this firewall to allow certain outside requests in, you can, just like you could restrict certain requests coming from the inside. But let's prove that the firewall with our simple configuration is indeed doing its job. So here we are in the inside device. I'm going to telnet into the outside device. If this works, then we've just proved that the inside has the ability to go out and the return traffic dynamically allowed. It worked just fine. We are telnetted into the outside device. I suppose we better grab the adaptive security appliance here, though, and make sure that this connection is actually showing up on it. So I'll do a show connection. There it is. Look at this. The connectivity through the device is being monitored. This is what's called a stateful network firewall. It is looking at and observing the state of this connection, and it is permitting it because it's inside to outside. All right, here's what we're going to do. We're going to go back to that inside device, and we are going to break that connection with an exit. So we're back. No telnet now through the device. And you guessed it, we're going to go to the outside device now, and we're going to try and telnet into the inside device. Telnet 10006, and it's going to try and try and try, and it's going to fail. Because this is a connection request from the outside world coming in, and the adaptive security appliance is correctly dropping this traffic. By the way, one note on this demonstration, we're using Telnet. Just because we're in a little lab demonstration here, we would obviously never use Telnet as a management protocol in our storage world because it is a clear text protocol. You would use something like Secure Shell as an encrypted alternative. Now, it's pretty ironic because what we were just doing was really concentrating on securing the physical infrastructure, like in a network situation, but we were using virtualized equipment in order to simulate that. Let's talk for a second about actually securing your virtualized environment, though. This can be super challenging today. Think about it. With multi-tenancy, we're really worried about data privacy, and some of the things that we really keep us up at night is the velocity of attack that can occur in a virtualized environment. So you could have an attack hit the hypervisor and proliferate through all the VMs, maybe even jump to another hypervisor and then start hitting those VMs. So an attack can really have quite a velocity. So we, as security administrators of the data center, go after physical security and hypervisor security. We try and isolate VM problems from each other. We try and harden those VMs. And of course, there's virtual firewalls and intrusion detection systems that can indeed help us when it comes to securing such a complex environment. Now, as far as concepts and action go for this particular nugget, I want you to focus on two families of stuff. There's RSA, and then there is the vShield family from VMware. RSA includes things like RSA Secure ID, which is two-factor authentication that provides an added layer of security to make sure that only valid users are going to get to our particular stuff. There's RSA Identity and Access Management, which provides identity, security, and access control management for physical, virtual, and our cloud-based environments. There's RSA Data Protection Manager, which enables deployment of encryption, tokenization, and enterprise key management, and it tends to be more simple and more affordable than other solutions. Then, as I alluded to, there's our vShield family. It includes three main products: vShield App, vShield Edge, and vShield Endpoint. vShield App is a hypervisor-based application-aware firewall solution. VMware's vShield Edge gives us comprehensive perimeter network security for our virtualized environment. And finally, VMware vShield Endpoint consists of a hardened special security VM with third-party antivirus software. As you might guess, I will include for you, since this is such a vast topic, detailed data sheets on both families of products. So I hope you enjoyed this nugget as much as I enjoyed making it. From losing my expensive pair of sunglasses to securing our storage infrastructure, we talked really theoretically, and then we got down to the nitty-gritty ingredients that we'll often use to protect the storage infrastructure. I sure hope you found this nugget informative, and I'd like to thank you for viewing.